Okay, we're going to go over the Unit 8 review. The test is Monday, so you need to make sure that you understand this material by the time we get there. Before we start to solve these quadratic equations, I want to remind you of a couple of things. We have 4 methods for solving. They include factoring, taking the square root, completing the square, and quadratic formula. These two, let me finish that off. Completing the square and quadratic formula are methods that work and can solve every single one, every single equation. I use factoring because it's faster, so that's a method that I like to look for, and square root method is a little bit faster too. So let's remind ourselves of some of the advantages of each. For the square root method to work, we need to have an equation that looks essentially like this. That term is missing. So we have a quadratic term and then constants, no variable to the first power. So let's take a look at the review and see if there are any problems that fit that. This one has a linear term, so it's no good. Linear term doesn't work. Linear term wouldn't work. But number 4, no linear term. See how we have quadratic, and then these are both constants, right? Okay, so let's go ahead and solve this using the taking the square root. What we want to do is get this to a place where it looks like x squared equals some number. So I'm going to start by trying to isolate this term. So I'm going to subtract 146 from both sides of the equation. And when I do that, I get negative 2x squared equals negative 180. I'm close. Don't square root here. Sometimes students try to do that and it's not quite there yet. What we need to do is get x squared totally alone. So I'm going to divide by whatever's in front of it. Once I do that division, I get x squared equals 90. Okay, now that I'm to that place, x squared equals number, what we can do is take the square root of both sides, and that'll help us find out what x is by itself. Remember that when you square root, we're solving for both the positive root, the principal root they call it, and the negative solution. 90 divides down into 9 times 10. 9 is 3 times 3. 10 is 2 times 5. So this is a perfect square, 3. This one's not, so it'll stay behind under the radical. So we'll get 3 root 10, and that's the solution. Okay, plus or minus 3 root 2 are the solutions. There's 2 of them. Let's keep looking. Linear term, can't do this with square root. Linear term, no good. No linear term on this one. Okay, sweet. So we can use square root method here. So I'm going to start by adding 7 to both sides. We will have 1/3 x squared equals negative 50. Then I'm going to divide both sides by 1/3. And I'll get x squared equals negative 150. Now that we have x squared alone equals number, we can take the square root of both sides. So we will get x equals plus or minus, okay, let's look at 150. It divides into 25 and 6, and 25 is a perfect square, 5 and 5. 6 divides into 3 and 2, so it's not a perfect square. So we're going to put 5 out front, root 6. Because this was negative 150, I have an I there, right? So this is an imaginary solution. All right, let's take a look at 8 linear terms, 2 of them. Okay, so over here we have square root method. I have already looked through every one to see what I could do on square root, and they're done. We only had 2 of them. That was all that we could do. The next one I most prefer is factoring. In order to get it ready to factor, I want to put it into standard form. So it looks like this. We've got all things on one side with the exponents decreasing, right? Second power, first power, 0 power, right? It's totally gone. And that's going to lead us to helping us know whether or not we can factor. After factoring, my instinct is to go to completing the square, and then, if that's possible, for that to be possible, I want A to be 1 and B, when A is 1, B is even. And then they're a pretty good candidate for completing the square. Even. And use quadratic formula as a last resort. It's time consuming. It does work for every time, but it's a little bit clunky in my opinion. Okay, so I'm going to look over here for ones that I can solve by factoring. I'm going to put this in standard form by subtracting x from both sides. Notice how 5x squared and minus x are not like terms, so when I subtract them, there'll be two different things there. And then I also want to add 2 to both sides. Again, 2 is not a like term to either of these, so we'll end up with 3 terms here. Now that I'm in standard form, I like to use this x method to check for factoring. So to do that, I'm going to take a times c and put those on top with b on the bottom. In this case, a times c, that's 10. And b looks like it's missing, but it's really a minus 1 right there. Now I'm looking for two numbers that when I multiply them, I get 10, but when I add those same two numbers, I get negative 1. I know that I can take 10 divided by 1 and get 1. 1 and 10, I don't think I can add those up to get negative 1 in any way. I can also divide 10 by 2. Then I have 2 and 5. Again, if I add those up, there's no way I can get to negative 1. So I've exhausted all my resources. 1, 10, 2, 5. Nothing else I can divide it by to get an integer. So this is not a factoring candidate. So next I'm going to look for completing the square. Before completing the square, I would need to get a to be 1, and right now it's 5, so I would divide every single term by 5. If I divide this term by 5, I would get negative 1/5, which is not even. So this one, I'm going to save and do, quadratic formula. I'm going to put a QF in the corner just to remind myself that I've checked for all the other options. This is a last resort that I've got to go back to. Let's move on to 2, see if we can factor this one. So we want to go to standard form. I'm going to start by subtracting the 9. We get x squared minus 14x plus 44 equals 0. Okay, if I factor, I'm taking a times c, so that's 1 times 44, and our b value on the bottom. Looking for two numbers I can multiply to get 44, but when I add them, I get negative 14. So 44 and 1. Since this is negative and this is positive, both numbers over here would need to be negative. So if I add those, I'd get negative 45. If I divide by 2, I'd get 22. So negative 2 and 22. I can't divide 44 by 3 and get an integer, but I can by 4. And negative 11. And if I add those, I get negative 15, which is close, but not quite there. And I think that's all that it divides into, 4, 2, and 2. So this one is not a candidate for factoring either. When A is 1, is B even? Yes. So this is a good case for completing the square. So I'm just going to write myself a note to come back and use complete the square on this one. Still just hunting for factoring. Okay, let's get this one to standard form and see if it factors. Going to subtract 6x from both sides. Not like terms, so I'll have 2 terms there. Then subtract 91 from both sides. Again, not like terms. So we've got this. Let's see if this one factors. A times c, that's negative 91. B is negative 6. So if I take negative 91 divided by 1, I get negative 91. If I add those, I'll get negative 90, so it doesn't work. Can't divide by 2 because it's not even. 3, 4, 5, 6, but maybe 7. If I do negative 91 divided by 7, I will get negative 13. And if I add those two numbers, I do get negative 6. So those are the two I was looking for. As I list my factors, it's going to look like x plus 7 and x minus 13. Now when I solve, I'm looking for what value of x will make that factor equal 0. So what plus 7 equals 0? It's negative 7. What value minus 13 equals 0? That's 13. We have these two answers. When you take the test, it might not be a bad idea to plug these in and make sure that they really work. That way you can check your work and see if you've solved correctly. Okay, that one was a factoring. Yay! 4 has been done. Let's look at 5. We want to get this into standard form, so I will subtract 7 from both sides. We have 3x squared plus 6x minus 69 equals 0. Factoring is easiest if we've removed all greatest common factors, and all of these terms are divisible by 3. So I'm going to go ahead and divide them all by 3. Now, if it ends up not being a good candidate for factoring, having divided by 3 is not going to negatively impact any other way that we might solve it. It would still be fine. Okay, I'm thinking this is not going to factor because 23 is prime, meaning I can only divide it by 1 in itself, and I can't use those to add up to get 2. So we won't be able to factor on this one, but notice that when a is 1, b is even, this could be a good candidate for completing the square. Come back to that in a minute. Let's try 6. So into standard form, I'm going to subtract 1 from both sides. So we'll have this. A is -1, so I'm going to divide every term by -1. I find that factoring when a is negative is tricky. Not worth the time that it takes to do it. So when we do a times c, we're getting 1. And b is -7, and 1 is prime? Well, it's not even prime, is it? 1 times 1 is 1. 1 plus 1 does not get us to -7. Even if I did -1 and -1, I would add and get -2. So this one won't work for factoring. Let's check completing the square. When a is 1, like in this case, is b even? And the answer here is no. So this would be one of my last resorts. I'd use quadratic formula for that one. Okay, 8 we did already. Sorry, 7 we did already. Let's look at 8. These two terms, notice that on this one, the term that's missing is our c. Whoops, 31 minus 3 is 28. When c is missing, we certainly can factor out an x of everything. So I'm going to go ahead and factor out even 4x. 4x squared divided by 4x just leaves us with x. 28x divided by 4x is 7. All right, so we could think of dividing each term by 4x. Okay, it's easy to see the solution here. X plus 7, what value for x will make that equal 0? -7. We have another x out here, and sometimes that one gets forgotten, so please make sure that you don't ignore that. If I'm looking for what value could I plug into x to make this equal 0, and it's not -4. If I did 4 times -4, I'd get -16, which isn't 0. But 4 times 0 would be 0, right? So one of the solutions here is just 0. Okay. All right, so we were able to do a couple of factoring problems. Maybe let's head to the completing the square problems next. We've got 2 of those. So in this one, what we want to do for completing the square is we want it to look like ax squared plus bx equals -c. We're going to move the constant over to the other side. And this works best when a is 1. So x squared minus 14x equals -44. Okay, for completing the square, what we're trying to do is build a perfect square factor so that we get something squared equals number. Then we can take the square root. Now, if I were to take a number and add it to itself and get -14, what would that number be? It would be -7. Another way to think of that is to say take -14 and divide by 2. Now, even though we're going to complete the square a handful of times, I'm just going to show you this one time in case you can't remember, that when we multiply this out, we'll get x squared minus 7x minus 7x, so together that's minus 14x, and then plus 49. Notice that to go from here to here, those are equivalent, here to here, these are equivalent, but our original is not. It doesn't match these, so there's something I need to add to it to get this to work. And the thing that I need to add to it is the 49. If I add 49 on one side of the equation, I have to add it to the other side in order to make the equation still work. We can do a side example of that if we want. You know that 3 plus 2 equals 5. That's true, right? What if I just go ahead and add 7 here? Is the equation still true? No. But if I add 7 over here, then it still is. So it seems odd to do that, but it sort of illustrates what we're doing here. Negative 44 plus 49, that's 5. Now we have something squared equals number. We can take the square root. So on the left we have x minus 7. Because the square root symbol and the second power, they cancel each other out. They're inverse operations. Equals plus or minus the square root of 5. 5 is prime, so I can't bring something out of the radical and leave it simplified. It takes one more step when completing the square. I need to get x alone. So I'm just going to finish off by adding 7 to both sides. So we'll get x equals 7 plus or minus the square root of 5. All right, we had one more completing the square, number 5. Let's hop to this one. Remember that I want ax squared plus bx and then equals negative c, so I got to move this to the other side. I'm going to add 23 to both sides, so I have x squared plus 2x equals 23. Okay, for my perfect square, I'm thinking of taking that and dividing by 2, which is 1. For the number I add in here, I'm going to take the square of that, which is 1, and add it to both sides. Now I've got quantity squared equals number, so I can take the square root. I get x plus 1 equals plus or minus, let's see, 24 divides into 4 and 6. 4 is a perfect square. 6 is 3 times 2, not a perfect square, so we're going to get 2 root 6. One last step to get x alone, I need to subtract 1. So this will look like x equals negative 1 plus or minus 2 square root 6. All right, we have 2 problems left, and they were both quadratic formula problems. Just remind yourself, you need to know this when you come to take the test, that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we're going to use that to solve this equation. It's a good way to solve for those that we can't solve any other way. Or if it's your go-to, you could use it for any of these and it will always work. In this case, a is 5, b is negative 1, and c is 2. We can grab that from this because we've already put it in standard form, ax squared plus bx plus c. If it's not in standard form, you need to be careful about what you're choosing for each of them. As I put it into the formula, I recommend using parentheses for every letter that you replace with a number. So x equals negative b, since b is negative 1, that's what goes there, plus or minus the square root of b squared, so I'm going to go negative 1 squared, minus 4 times a is 5, times c is 2, all over 2 times a. All right, to solve this, I recommend putting these numbers in your calculator. You can do mental math, but also maybe check it with your calculator. It's easy to make errors there, mental errors. So I'm going negative 1 squared minus 4 times 5 times 2, and I got negative 39. So I'm going to simplify as I rewrite it. Negative 1 is positive 1, plus or minus, whoops, that's not a 1. 1 plus or minus the square root of negative 39 all over 10. 39 divides into 3 and 13. Those are both prime, so no perfect factor we can take out. But take a look at this negative. So we do want to simplify there. We will end up with 1 plus or minus I root 39 all over 10. Okay, let's try. Number 6 was the other one we said we could do using quadratic formula. So a is 1, b is negative 7, c is 1. Again, they're easy to see because we've already put it in standard form. Okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I'm going to work on finding just the discriminant, these numbers right here, and it's going to end up being 45. So we get x equals 7 minus negative 7 is 7 plus or minus the square root of 45 all over 2. 45 divides into 9 and 5, so I can rewrite that as 7 plus or minus 3 root 5 all over 2, and that's the end. I want to solve one that ended up factoring maybe using the quadratic formula. So let's come do 3. We've already done it, but I just want to show you some nuances of the quadratic formula when it can be simplified a little bit. Okay, so at this step we've got it in standard form. A is 1, B is negative 6, C is negative 91. So as I write this in quadratic formula, we're going to get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I haven't found this discriminant yet, so let me try. Negative 91, and I got 400. So as I rewrite this, I'm going to get minus negative 6 is plus 6, plus or minus the square root of 400 all over 2. The square root of 400 is 20. So now I have 6 plus or minus 20 all over 2. At this point, I would rewrite it in 2 ways because the radicals are all totally gone. So I want to find out what is 6 plus 20 divided by 2, and I want to find out what 6 minus 20 divided by 2 is. 6 plus 20, that's 26, divided by 2, that's going to be 13. 6 minus 20, that's negative 14, divided by 2, so that's negative 7. So you can see that either way we solved it, we got the same answers, as long as we're using our math carefully as we go. All right, then we move into some story problems. This one doesn't yield an integer solution, which is somewhat frustrating, but also definitely possible that we can do this. So, the chicken coop at the petting farm is 10 by 14 feet. So it's some rectangle this isn't a great picture, but 10 by 14. The farm would like to double the current area. I'm going to pause here. What's the current area? If the coop is 10 by 14, then the area is 140, right? If they want to double the current area, that means times it by 2. So that would mean the new area is going to be 140 times 2, which is 280. Okay, let's go back to the story and see what we get. I need a small eraser here. Okay, now it says they want to double the current area by adding the same amount, x, to the length and width. Okay, that was a big key that they gave us with x. That was nice. So we're going to add the same amount to the length and the width. So I'm going to add x to 14, and I'm going to add x to 10. If we write the x's in front, then it's a little bit more like what we're used to, x plus 14 and x plus 10, but we can certainly solve it this way too. What are the dimensions of the new enclosure? Okay, they want the area to equal this. We've got a new width and a new length. Let's take these and multiply them together. Length times width equals area. So we'll do 14 plus x times 10 plus x equals 280. You should already know how to multiply this out quite well. That's a skill that we've been practicing for a long time. These two are like terms, so we will add them together and get 24. Okay, this is not in standard form, so I'm just going to move it into standard form by just rewriting things. So x squared first, then 24x, then plus 140. Okay, one more step. We want to set it equal to 0, so I'm going to subtract 280 from both sides. X squared plus 24x minus 140 equals 0. Okay, I have tried to factor this because I like factoring, and that would make us get a nice, easy solution, but I found that I couldn't. Let me show you what trouble I ran into. So to multiply and get negative, one of my numbers needs to be negative, and when I add to get positive, the bigger one needs to be positive. So if I had like -1 and 140. or negative 2 and 70. If I add those, I'd get 68. I could try 140 divided by 3. Nope, 140 divided by 4. That's negative 4 and 35. If I'd add those, I get 31. 140 divided by, let's see, it looks like 10 would work. Negative 10 and 14. If I add those, I'd get 4. Uh-oh, my numbers are getting a lot smaller. That's 24, by the way, not 29. 29 would have worked. So as I keep moving forward, I can see that I'm not going to be able to come up with the solution by factoring. We could do completing the square. In fact, sure, why not? Let's do completing the square. So in this case, we want to move that 140 to the other side. So we'll move 140 over. We get x squared plus 24x equals 140. Our factor is going to be half of that, so x plus 12. 12 squared is 144, so that's what I'll add to both sides. So we get x plus 12 squared equals 284. Now I can take the square root of both sides. I'm running out of room. X plus 12 equals plus or minus, let's see, 284 divided by, 284 divided by 4, 4 and 71. 71 prime. Let's see, square root of 71 is 8, so I just need to test up to 8. It's not even, not a multiple of 3, 4, 5, 6, 7. Nope. Okay, so this would simplify to 2 root 71. Okay, well actually, when we're solving story problems, we don't care about simplifying. So sorry, let me go ahead and leave that root 284 because what we're going to do is try to get a decimal approximation. So let me solve for x first. I can do that by subtracting 12 from both sides. Okay, I'm going to try and find some space where I can rewrite this. So we get x equals, sorry, let me remind myself, negative 12 plus or minus the square root of 284. Okay, we want a decimal approximation, so let's take this in two directions. I'm going to look for negative 12 plus root 284 and negative 12 minus root 284. And we're just going to do a decimal in both cases. Negative 12 plus root 284. In that case, I get 4.8522995546. So we'll start at 4.85. If I go negative 12 minus root 284, I get negative 28.85 stuff. Okay, one of these answers doesn't fit our story. If I were to take negative 28.85 and add it to 10, I would still get a negative answer, which doesn't make sense for the dimensions of the coop, chicken coop. But 4.85, that's positive, that one does work. So the amount x that I want to add to both the length and the width is 4.85. And they're asking, the question says, what are the dimensions of the new enclosure? Well, if we have x is 4.85, what we're going to do is take that x and add it to 10. So one dimension is 14.85, and the other we would take x and add it to 14, we said, right? So that one's going to be 18.85. So these are the new dimensions. Let's check the labeling. They said feet. We can check our work. If we do 14.85 times 18.85, we need some number that's pretty close to 280, and it is 279.92 stuff. So we're on the right track. All right. Next one. Find two consecutive positive odd integers. Consecutive means one right after the other. Odd integers means that I'm going to skip over the even number. So if I write an expression for two consecutive positive odd integers, the first one's going to look like x. And if I pretend that it's an odd number like 3, to get to the next odd number, what would I have to add to that? I'd have to add 2 so that I could get to 5, right? So it may be 3 and 5, but it might be something different. We're just going to do these two. This one would be considered smaller, and this one would be larger. That might help us as we're trying this problem. Two consecutive positive odd integers such that the square of the smallest, so I'm going to take this one and square it, added to 3 times the larger integer. So here's my larger integer. When I do 3 times that, I need to include parentheses because it's a binomial. So 2 terms, need to make sure that 3 multiplies by all of those. Then they use the word is equals 24. All right. Let's see, 75% of the battle is coming up with the equation. So if you've gotten that far, that's really good. Now it's just a matter of algebra to solve it. So we're going to distribute this 3. We'll get x squared plus 3x plus 6 equals 24. To get it into standard form, I'm going to subtract 24 from both sides. X squared plus 3x minus 18 equals 0. I'm going to see if I can factor this. A times c is negative 18. B is 3. Let's see, I think 6 and 3 would work here because 6 times 3 is 18. And if 3 is negative, then I get negative 18. And when I add them, I get positive 3. So our two solutions come from the factors x minus 3 and x plus 6. What value of x is going to make x minus 3 equal 0? It would be 3. What value would make something plus 6 equal 0? It would be negative 6. Okay. Because the story problem asks for positive, odd integers, negative 6, even though it's a valid answer for mathematical equation, does not fit this story. So we're left with the solution of 3. Now it did ask us to find 2 answers, so just 3 is not going to cut it. But since x is 3, the other one, x plus 2, that would be 5. 3 plus 2 is 5. So there's our 2 answers, 3 and 5. Now we can also double check and make sure that it fits the story problem. So let's do that. The square of the smallest, that would be 3 squared, added to 3 times the larger, 3 times 5, is 24. So we could pop that in our calculator and check. That would be 9 plus 15, that is 24. So we got the right answers there. Okay, I gave you the equation for how to solve these two when you were in class. So for Alex, the equation is y equals negative 16x squared, and he used initial velocity of 60 plus 60x, and he was 40 feet high, so plus 40. Okay, I'll give you the equation on the test. You don't need to worry about coming up with it. And then Josh also threw his textbook off the building. His equation looks like y equals negative 16x squared. His velocity was 48, and he also started at the top of the building, 40 feet up. Whose textbook reaches the ground first and by how many seconds? Okay, when we're doing a story like this, we're thinking about, maybe a better picture is here they are on the building. They throw it off. When does it hit the ground? We want to solve to find that. Quadratic formula is a great one to use when we've got numbers like this. It's already in standard form. A is negative 16, B is 60, and C is 40. So let's work on getting this one right now. It's going to look like x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I've solved this one. What I would do next is find the discriminant. So x equals negative 60 plus or minus the square root of 6160 all over negative 32. What I would do now, since we're looking for a story problem, is just go ahead and put this in the calculator and look for a decimal approximation. In one case, I'm doing negative 60 plus root 6160, and in the other I'm doing negative 60 minus root 6160 all over negative 32. As you solve each of those, you're going to come up with decimal approximations. The plus is going to lead to negative 0.5777. And this one is going to lead to 4.328. Negative answer doesn't make sense. Traveling backward in time wouldn't work, so 4.328 is the one we want. So a lot of calculator work to help us get there. Let's check out Josh's and see how long it takes for his to reach the ground. So in this case, A is negative 16, B is 48, and C is 40. So we want x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. When I simplified the discriminant, just this stuff, not even the radical, just the stuff inside, I got square root of 4,864 all over negative 32. Again, I would do the two ways, so negative 48 plus root 4864 all over negative 32, and in that case I got negative 0.679. Doesn't make sense in the story problem, so we'll disregard that one. Then if I do negative 48 minus square root of 4864 over negative 32, I get 3.679. Okay, whose book hit the ground first? Well, I think Josh's, right? It hit in 3.679 seconds, and it took Alex's book 4.328 seconds. So Alex threw it harder. It took his longer to reach the ground, actually. Probably flew a little farther. So we want to find out who's reached first, Josh, and by how many seconds. So we can find that by subtracting. If we take 4.328 minus 3.679, we get approximately 0.649 seconds. All right, last one. Is the bell gonna ring before I finish this? Oh, I might be able to get it done. Okay, a quarterback throws a football from a height of 6 feet. So again, I'll provide you with the equation. Plus 20x plus 6. Find the range of the function. For the range, we want to find out what's the highest point that the ball goes to. So this is a great one for finding the maximum. And remember that when we want the maximum, we don't need to solve. Instead, let's use the vertex. So we're going to use the formula negative b over 2a, and then we're going to plug it in to find the second number in the vertex. Okay, so a is negative 16, b is 20, and c doesn't actually affect the first term of the vertex. So we'll ignore that for now. We're going to take negative b over 2 times a, and I got, equals 0.625. So that's how long it takes for the ball to reach the highest point. That's our first number in the vertex. To get the second number, which is going to tell us how high the football went, we need to plug it in. So I'm going to replace every x in the equation with 0.625. And when I do that, I get 12.25. So that tells me at the highest point when he throws the ball, it goes up to 12.25. If I were drawing a picture of this, he's 6 feet tall, so it kind of goes like that and then hits the ground. The range that we're talking about for this story goes from where the ground is to the highest point of wherever the person threw the ball. This isn't actually a very perfect picture, but it'll do. So the range is going to be from 0 up to the highest point that we've got, which is 12.25. If we were finding domain, if it asked for domain, we would solve to find this number, right? And then we would say the domain was from 0 until whatever that number was when the ball hits the ground. Okay, I'm going to stop there, and then I'll put on a second video where I go over the problems from the second page if you are interested in following along for that.